All right, number 7. So the figure at the right shows an arrangement in which 4 discs are suspended by cords. The longer top cord loops over a frictionless pulley and pulls with a force of magnitude 98 newtons on the wall to which it is attached. The tensions in the 3 shorter cords are blah, 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 blah. Find the masses of the things. Okay, so basically what we've got then is this. So we've got A, B, C, D. And then they're connected by strings, tension 1, tension 2, tension 3, and then the whole thing is supported by a force there. So that first, or I guess the second sentence, the longer top cord sentence, it says it pulls with a force of 98 newtons on the wall. So what that's telling you is that over here at the other end of the thing, there's a tension force this way pulling on the wall with a force of 98 newtons. So what was the point of that, you guys? Why do we care about the tension on the wall? Yeah, good. A lot of you are mumbling about the tension. Yeah, the tension is the same at both ends, right? So if the tension at this end is 98 newtons, then the tension here is 98 newtons. Did I say that right?
Yes.
Okay. Let's see. So I think you can, and maybe this is what messed people up, I think you can fairly safely assume that the system's not moving, right? Because the wall's not going to move, and the ropes are always unstretchable. So, so based on that, doesn't that mean that the total mass has to be, well, the total weight has to be 98 newtons? Which means our total mass has to be, what, 10 kilograms? 98 over 9.8? Follow? Okay, so let's see. It gives us the tensions in the 3 shorter cords. So it tells us that this tension is 58.8 newtons. This tension is 49 newtons. And this tension is 9.8 newtons. So let's pause for a minute. Even without doing any math, I want you guys to notice something really important about those numbers. General trend for the numbers as you go down the list. What are they doing? Decreasing. Why would that make sense?
Less weight.
Because each cord, the farther you go down, the less weight you're suspending, right? Tension 3 is just holding up disc D, right?
Yep.
Tension 2 is holding up disc C and D. And tension 1 is holding up the bottom 3. Follow? Okay? So if I make a free body diagram for disc D, here's my deal. I know that there's a tension force supporting it that's 9.8 newtons. So what does the force of gravity have to be, you guys? Negative 9.8 newtons, right? So what's the mass? 1 kilogram, right? Because 9.8 newtons is 1 kilogram, right?
Yep.
Follow? Okay. Then you can repeat that process for blocks C and D, right? You've got 49 newtons pulling up, which means that the weight of those must be 49 newtons. So that's a combined mass of 49 over 9.8, so that's 5 kilograms, right? And you know 1 kilogram is D, so it must be 4 kilograms for C. Seba?
Can you just subtract 49 and 9.8? Yeah.
Oh yeah, sure, you could do it that way. So if you want to go that route, then what you're actually doing, and this is not a bad option, what you're actually doing there is you're saying, all right, here's block C. I know that the force of gravity is pulling it down. I know that tension 3 is pulling it down with 9.8 newtons. And I know tension 2 is pulling it up with 49 newtons. And I know my net force is 0, and solve for Fg. Yeah, and then that tells you that Fg is 39.2, which corresponds to a mass of 4. That works also. Yeah, that's slick. I like that. That never occurred to me. Okay, is that enough on that one? Do you guys want me to say more? I don't remember who asked about that one now. Everybody good with 7?
Yeah.
Is anybody lying?